Looking at the gaseous phase reaction of hydrogen iodine decomposing into hydrogen and iodine, and we're going to do kinetic studies. And what we've done is we've started with 3 different initial concentrations of hydrogen iodide, and we've measured the initial reaction rate. From this data, we can calculate K and M. Once we know K and M, we can then predict the rate from the rate law for any unknown or given initial concentration. Okay? We're going to start with the 2-state approach. Okay? So I could take any state, R1, and that would be equal to K times HI at that state to the power of M. I could divide both sides by R2. Okay, and if I divide this by R2, they become equal. But I know that R2 is equal to K times HI state 2 to the power of M. Now my K's cancel, so this becomes equal to HI at state 1. And these are both to the power of M, so I can put them under a common thing here, over HI2 to the power of M, okay? Now I want to solve for M, okay? So I can algebraically brute force through this, and we will in a minute, okay? How do I solve for power? I take the log, okay? I use the relationship x equals a to the k, log of x equals log of a to the k, which equals k log a, okay? So I'm going to take the log of both sides, so I have the log of R1 over R2 is equal to the log of HI1 over HI2 all to the power of M. And now using this relationship here, which is equal to M on the log of HI1 divided by HI at state 2. Okay? Now I can solve for M, and I can say that M is equal to the log of R1 over R2 divided by the log of HI1 over HI2. Now I've worked this way through this, and there will be times when you have to be able to do this. But one of the things I want to teach you is that we can pick data that simplifies the math, okay? So I could have chosen, let's say the top state at 0.05 is state 1, the next state, initial concentration at 0.1 is state 2, and the bottom state up there is state 3. I could have chosen any state I want, okay? If I had chosen state 1 and 2, if I compare 2 to 1, I see I doubled the concentration, okay? And in our minds, it's very easy to understand 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, okay? So what I'm going to do is I'm going to take state 2 over state 1, because when I divide the concentrations, that equals 2, okay? So let's look at it. If I take R2 over R1, that's equal to the HI at state 2 over the HI at state 1 to the power of M. Okay, I simply substituted into this relationship here, except I'm doing state 2 over state 1 using the data up there. So now I substituted my data, and one other thing I notice, okay? If I look at my rates, the top one is times 10 to the minus 10. That number is smaller than 10 to the minus 9. So if I multiplied all 3 of those values by 10 to the 10, the numbers change, but the ratio doesn't, because if I multiply this by 10 to the 10 and this by 10 to the 10, that equals 1, okay? So I'm going to make life easier here, and I'm going to say R2 is equal to 35.2. 35.2, divided, because I multiply it by 10 to the 10, and divided by 8.8, and I get rid of the 10 to the minus 10 because I multiplied it by 10 to the 10, okay? If you don't understand this, pull out your calculator and try it, okay? So this is the ratio of R2 over R1. I could have multiplied each of these by 10 to the minus 10 and have the numbers on the sheet, but 10 to the minus 10 over 10 to the minus 10 is 1. The ratio doesn't change. This is equal to, now what was my initial concentration for state 2? It was equal to 0.1. What was my initial concentration for state 1? It was equal to 0.05. Now, and this is all to the power of m. Now I get out my calculator, okay, and I can take 35.2 divided by 8.8, and I get 4. And 4 is equal to, if I take 0.1 divided by 0.05, that is equal to 2 to the power of m. Now, I don't need to solve this. I don't need to use logarithms. Off my head, I can tell you that 2 squared equals 4, okay? That's because I chose some good data, okay? But you might be given an exam problem where you haven't squared something, so it's not easy to see it, okay? So if I was, let's say I just brute force did this and I used experiment 3 and experiment 2, okay? So this becomes log of R3 over R2 divided by log of HI at 3 over HI at 2. Now, what I'm trying to say here is it doesn't matter what states I use as long as I consistently have this state and this state. Okay? So I'm using the data from state 3 and state 2 as up there. So this becomes the log of R3. Okay, so that's 7.92 times 10 to the minus 9 divided by R2, so R3 over R2, which is 3.52 times 10 to the minus 9, but the 10 to the minus 9 over the 10 to the minus 9 cancels, so I'm just going to keep my board clear here. Now I get the log here of HI in 3, which is 0.15 over 0.10. Okay, and students will often make a big mistake. They'll take this times this, and then they'll bring this, and they'll take the log of both. I'll show you in a minute if I have room on the chalkboard, but that's a mistake. So this is equal to, what is the log? So 7.92 divide by 3.52, and the log of that is equal to 0.352. Let me switch this. 0.352. And here I have the log of, I have 0.15 divided by 0.1, so that's equal to 1.5. And the log of that is 0.176. If I take the reciprocal of that, multiply by 0.352, I get 1.99896, which equals 2. Okay? So realize this was much easier and actually came up with a more exact answer because I truncated these. Okay, so I know this is 2. Okay? I now need K. Okay, I pick an easy value. Okay? I can come back up to this equation here. Okay? And I can say K is equal to, I've got R on the numerator, and now I've got the HI concentration to the power of 2, because I know M, okay? Now, I could choose any of those data points. Why not choose a data point that the math is easy? If I look at experiment 2, I have 0.1, okay, multiplying, so I have 0.1 squared. That's real easy math, okay? So I can now say that this is equal to, and I take the data from experiment 2, which is 3.52. 3.52 times 10 to the minus 9. Now we need that minus 9, because I'm not taking a ratio. It doesn't cancel, okay? Divided by 0.1. Now what is 0.1? That's 1/10. 0.1 squared. So really, I'm simply multiplying this by 100. In other words, it's the same thing as going by 1/10 squared. So that comes up here. So the final answer is 3.52 times 10 to the minus 7. Okay? Now by choosing the data value that was the simplest, I came up with the easiest answer. Now, one other thing I should comment. We have the units here, okay? What are the units of R? The units of R are concentration or molarity per time. This is molarity squared. So what we have here is, when we brought this down to here, we have reciprocal, where is it? Right here. We need to add the unit, so it's reciprocal molarity times time. And I'm just going to write seconds, okay? So reciprocal molarity seconds, okay? All right, hopefully that helped.